Okay, hello everyone. This is Anthony Alaka with Torrey Hills Capital, and welcome to the Ventripoint Diagnostics podcast for February 18th, 2021. Happy New Year to everyone. I hope you're all doing well under the circumstances, and here's hoping that things will start getting back to normal again in the coming months. We are very excited to bring you Ventripoint Diagnostics today. The company's recent performance has been nothing short of amazing as they've made some key announcements that have really put the company in a position for continued success. We believe their technology is a game changer in the medical imaging space for many reasons, and we feel that based on current fundamentals, the stock presents an excellent value for investors. Ventripoint Diagnostics is a commercial stage AI healthcare company that has developed an extremely valuable diagnostics platform, which addresses a very large unmet need in the medical scanning space. Ventripoint's platform enables the massive in-place fleet of two-dimensional ultrasound devices to create highly detailed and accurate three-dimensional views of the heart. Prior to the introduction of Ventripoint's solution, the only way to get this data was using MRI technology, but the use of that equipment to perform this task had a number of significant drawbacks, which we'll cover during this call. These limitations to using MRI to scan the heart have really created a massive market opportunity for Ventripoint to move this platform into the healthcare community in a big way, which we'll also be discussing during this presentation. Ventripoint Diagnostics trades on the OTC market under the ticker VPTDF and on the TSX Venture Exchange under the ticker symbol VPT. Ventripoint shares are currently trading around 33 cents per share US, representing a market cap of roughly $25 million US. And although the stock has performed very well as of late, we still feel there's plenty of upward potential as the company continues to execute its growth strategy. With us today to discuss Ventripoint Diagnostics and their growth strategy going forward is the company's Executive Chairman and CEO, Dr. George Adams. George, welcome.
Glad to be here, Anthony.
Well, it's great to have you, and thanks for taking the time today to bring our viewers up to speed on Ventripoint Diagnostics. And I just want to say before we get started, if our viewers have any questions during the presentation, feel free to click the raise your hand icon and I can unmute your microphone, or you can simply type your question into the chat box and we'll make sure it gets read to George. I'll now turn it over to George Adams. George, the floor is yours.
Thank you. Well, good day. Ventripoint is a diagnostic company. It deals with 2D ultrasound of your heart, and it's an artificial intelligence approach to analyzing the images, the standard images you would get from an echocardiogram, for all four chambers of the heart. So we have our product is licensed for sale in the United States, Canada, Europe, and in China. And we now have 16 sites actually up and running, 5 more recently in China, and 11 more that we want to do. We're trying to get to a target we have for the company is to get to 80 to 100 units clinically used by middle of next year. And we'll talk a bit about why that's an important threshold for us. So when you go and have every cardiologist in the world has access to echocardiography device, ultrasound device, 2D ultrasound, and standard exam is 16 views through 4 different acoustic windows, shooting the sound between your ribs and getting 2D slices right through your heart. It works reasonably well. And it's sort of a whole lot better than a stethoscope. Listening to your heart, actually seeing it beat is a big upgrade. But it still doesn't give very accurate and reliable volumes for all the different chambers, and especially very bad to your right ventricle volumes and ejection fractions. And if you're born with a problem, if you're a child with a heart problem, it's almost always the right ventricle where the problem is. And so this is especially difficult for children. To get any kind of a decent picture and analytics on the volume and ejection fraction and overall function of your heart, you have to have an MRI. They're both expensive. They take a long time to get them queued up. They actually have an appointment to do one. And there are a number of other advantages. So the first disadvantage of an MRI is you have to be in there for an hour to 2 hours motionless. You have to be sedated because most people don't like lying in a very confined tube, but it's very noisy. and very claustrophobic. And they also have to inject you with contrast media when they want to take a picture. So people don't like needles, don't like MRIs either. It takes, a few days to get the images analyzed and sent back to your cardiologist. MRI machines are expensive things to buy and expensive things to run. And as one CFO of a hospital said, and the wing on the hospital you have to build to put it in, because you can't have any reinforced concrete anywhere near it, is the most expensive part. So Ventripoint has evolved a way to analyze the 2D ultrasounds to give you exactly the same information that you get from MRI, with the same accuracy and the same precision and reliability. It takes 5 minutes to scan. Patient can move around while the images are being collected. There's no sedation or contrast media required most of the time. And you get the images immediately. You can analyze them in 5 minutes, and the cardiologist can look at them right there. And we have a tool that allows them to scan through the study in less than a minute and convince themselves it's a good study and the numbers are correct. So this is what, on the left-hand side here, you'll see this is the VMS 3.0. It's a stand with a computer. All the magic is in the software. We hook it up to anybody's ultrasound machine. This happens to be a Philips IE33 top-end machine. There are 2 wires coming out of the probe that's on the patient's chest, which is collecting ions. The first wire is the images going into the ultrasound machine. The second wire is a tracking device. And this square thing here is a crystal that we put on there along with the ECG lead. It's a consumable, and that allows the patient to move around because we know where the patient is, we know where the probe is, and we can tell exactly where that slice is when the image is collected. It's taken us 10 years and over $30 million to develop this thing so it fits smoothly into the normal workflow of any echocardiography suite and echocardiography process. And that's why we're very excited to be able to now market this device to all the cardiologists in the world. So this is what it looks like when you take a 2D slice of your heart. If you're an echocardiography, these are 3 different views from 3 different angles. You and I probably don't know much of what these would look like, but in fact, echocardiography, this is what they're used to looking at. And they have to imagine in their mind, what is the 3-dimensional structure of this? And they don't get good numbers if they can't really figure out what it is. So we turn those images into a 3-dimensional model of the heart, all the different chambers, in this case, the right ventricle. And let me show you how we do that. So this is a slice of the heart. It's an apical view. It's a 2-chamber apical view. The left side over here is actually the right side of the heart. So there's a mirror image, and the top is actually the bottom. So we aim to put dots on various, identify the inside wall, the outside wall, every side of the valves. They're color coded, so the operator can understand whether they're trying to do valves or walls, inside walls, outside walls, or the apex. We now have a constant, because we can know where those dots are in 2-dimensional space. We also know where they are in 3-dimensional space because we know where the plane is. We can then go, and the second part of the magic is we have collected a database of all the weirdest shaped hearts you can imagine. And then we use our particular kind of artificial intelligence called KVR. And we go and get the best fit model to the points that have been identified. And that's how we get to be exactly equivalent to an MRI and just as accurate. You can touch any one of those dots and you'll see where the plane goes actually through the heart. You can see this yellow border line, which tells you where the heart is in that 2D slice. You would have never thought that's where the heart was, or what that part of the heart was there in this slice. So a cardiologist and sonographers all love this because they can actually see how good a study they've done. And again, this is part of the process cardiologists will go through, saying, yes, there's good alignment between the borders and where I think the heart, where I normally would say that's where the heart is. And so they can believe the numbers. The numbers, as I said, are identical. These volumetric numbers, so you get the volume of the heart when it's full of blood, the volume of the heart when it's pumped out as much blood as it's going to pump, and that's called and the difference there is called the ejection fraction. Normally, you would pump out, 50 to 45, 50% of the blood on each beat of the heart, and a number of other parameters that are standard parameters. We've been through the FDA 3 times. We've been through Health Canada 3 times. We've been through CE Mark 3 times. We're compliant with all standards and codes in all 3 jurisdictions. And And the first one was for right ventricle only. The second one was for all 4 chambers. And the third one here is because of our new tracking device, which allows patient movement. So we actually had to invent one of the biggest complaints about version 2 was that the patient had to remain motionless, just like they do in an MRI. It was only for 5 minutes, but still patients complained and the operators complained. So we invented a brand new tracking system to allow patient motion. So that's one of the fundamental differences between version 2 and version 3. And that's allowed us now to get past all the barriers to entry here in terms of usability. We're focused on some key market segments. The first one is congenital heart disease. As I told you, if you're born with a heart problem, it's the right side of the heart. Standard of care calls for a patient to be scanned every 3 months for their whole life. There are now more adult people with CHD than children because they now live to be more or less a normal lifespan. 30, 40 years ago, they would live to be teenagers, and then that would be it. Pulmonary hypertension is what happens when you get, well, you all know hypertension, blood hypertension, that's the left side of the heart. The right side of the heart pumps the blood through the lungs and over to the left side of the heart. So whenever you get any kind of congestion in your lungs, COPD, lung cancer, COVID, the right side of the heart has to pump harder. So you get higher blood pressure to get enough blood through your lungs and over to the left side. The left side pumps it out to the rest of your body. You can die from right heart failure. You can die from left heart failure. You can die from biventricular failure. So it's important that both sides of the heart work effectively. Another concern that has been another market that we're addressing is the cardiotoxic effects of chemotherapy. So we've been using the same 3 chemotherapy drugs for the last 30 years. There's no doubt 20 or 30% of the people who get those drugs that put their cancer into remission, then 20 or 30% have chronic heart problems, and they're now more likely to die from a heart damage than they were from the original cancer. And so they now have to be studied like the CHD people and like the pulmonary hypertension every 3 months to make and their therapy adjusted depending on how their heart is coping with all the damage that was done during the chemotherapy. COVID-19 patients are also now high on our list because it's now showing that 40% of people who get infected with COVID have enlarged right hearts, and an additional 20% have dysfunctional left hearts. So 60% of people who get COVID, and it's not really correlated to how bad the symptoms are. Yes, the worse they are, the better, but you can be totally asymptomatic and have a really damaged heart from being infected with COVID. There's been some, headline cases like Major League Baseball pitchers and football players and people like that. So athletes who were in a peak shape, and yet when they got COVID, their heart was severely damaged and had to be sent home for many months of recuperation. And the last one is that we've just opened is companion animals, dogs, and I'll say a bit more about that later. Heart disease is still the #1 problem worldwide. It consumes a massive amount of healthcare dollars, billions and billions of dollars, trillions of dollars if you look at the whole world. And you need a better way to diagnose heart disease and follow people who have heart disease and make sure the therapy that you're applying works. So we're rolling out our machines in the very highest profile centers that we and we're very happy to get them into the hands of the knowledge and opinion leaders of the cardiology community. So the first one we put out was in September in Erasmus, which is the #1 cardiovascular hospital in Europe. It's about 15th worldwide, and they use it on all patients. They get referrals, very difficult heart cases from all over Europe. Second one we put in was MD Anderson in October. MD Anderson has been the #1 cancer center for 30 years worldwide, and so they are using it on obviously cancer patients, both during the actual therapy, between each session, to try and get a better idea of how much damage is being done and maybe adjust the schedule, as well as post chemotherapy to monitor people and try and find out exactly how to treat them better. Third one was in Peter Munk Cardiac Center in Toronto at UHN, and it's the largest cardiovascular center in Canada. They have a huge pulmonary hypertension and adults CHD congenital population pool. So they're using it on those. And the last one we put in just before Christmas was King's College in London. That's the epicenter for the COVID variant, UK variant. They're using the device on COVID patients. The next one we put in will also be in the UK at another COVID specific site. The UK has now opened 40, or in the process of opening 40 specific COVID sites, because they have so many people with long COVID symptoms, cardiac problems, respiratory problems, all sorts of problems. And so they are opening special clinics for that. We're starting to do that in Canada now. That's also happening in the United States. They're trying to get these COVID patients out of the main hospital streams, let the hospital get back to doing what they do, treating all sorts of different diseases, including cardiovascular disease, and let the COVID people go to a special clinic. So we're now addressing that opportunity. So the go-to-market strategy for the company is pretty much the same one that every medical device company in the world ever had, was get your device in the hands of the key opinion leaders, let them use it, let them talk about it at conferences, and let them refer you to their colleagues who need it and get. In the modern world, of course, we're going to do webinars. So we now have 2 webinars planned in between now and the end of the quarter, to have these KOLs get on the web and talk to 2 or 3 other cardiologists and present a case and explain why the VMS has been so effective and useful for them in particular cases. So that's a tried and true method, and that's where we're headed. The market opportunity here, just if you look at oncology, pulmonary hypertension, and congenital heart disease in US, Canada, and Europe, is about 40,000 machines. We sell the devices for $50,000 each. We also have a leasing option, which we'll talk about next. So it's a $2 billion opportunity minimum. If you add COVID to this, if COVID is anywhere near as bad as it's looking, we will be in, we can double all these numbers. So we historically have sold the device for $50,000 with a $5,000 a year annual recurring revenue. And now we have a consumable patch, which they also have to buy for each procedure. In the United States, there is actually a reimbursement code, which is 76377, and we've been assured by the American Society of Echocardiography that code can be used on what we do. And so the minute the machine is up and operational, because it's FDA approved, they can start billing that code. They get paid back anywhere from $98 to $200. So we have a leasing program now, which says you can lease the device for $15,000 a year. The first 200 cases are free, and then it's $50 a case thereafter. That's meeting with very warm reception in the United States. Because break even for them with 75 to 150 cases, they've paid for the leasing fee, and now they start making more and more profit off of depending on who's paying the bill. 75 to 150 cases is a couple of weeks work in most cardiovascular centers, so it very quickly becomes a profit center, this device. So as I said, we have 16 sites, 5 in Canada, 1 in the US, 1 in the UK, soon going to be 2 in the UK, 1 in Europe, and 8 now in China, soon to be many more. And really, these are first sales to first sites. Every hospital of any size would need many of these machines. For example, MD Anderson treats 1.5 million people a year with cancer and manages their care. To do that many people, you would need 1,000 of our machines to adequately manage those people. So, MD Anderson, when they get finished evaluating the device, they will for sure start ordering many more. We've just announced a collaboration with the veterinary school at North Carolina State University, and for dogs. Let's see whether our databases work correctly on dog reconstructions. We've done a dozen cases now, and they work perfectly fine, because dog hearts actually aren't that much different than, slightly deformed normal hearts, human hearts. And so it's a huge opportunity, because 37% of households in the United States have adopted a pet in the last 12 months pre-COVID, because for companionship. There's now 100 million companion dogs in the United States, and about 10% of those have heart disease. So there's actually more vets in the United States, 30,000. There are only 25,000 cardiologists in the United States. So there are more patients and more doctors to deal with companion animals than there are humans. And horse racing, racehorses are another big application area for that. And we're working now to again, validate our system. There's no regulatory here, so we don't have to go through any, once we have the data that shows we can do as good a job as MRI on a dog, we can immediately start selling the product in that market segment. Back to so the way our industry works, ultrasound, cardiac ultrasound especially, there's only 3 players. There's Philips, Siemens, and GE. And the reason there's only 3 is because they buy everybody else when they stick their head out of the weeds, and sticking your head up out of the weeds in this particular context means having 80 to 100 customers. Once we hit that range, that's the tipping point where Philips or GE or Siemens, and there's some other players out there, Mindray, Samsung, have visions of becoming a major cardiac player, but they usually are slower to the table than the big 3, and so they haven't made a lot of big acquisitions. Although Samsung did buy Medison for about $300 million a number of years, and that was strictly for a cardiac ultrasound play. So the latest acquisition has been about 3 years ago, which was Philips bought TomTec. TomTec was another analytical company, very similar to us. They paid more than $100 million. We don't know how much more. It could be 200 million. I'm not sure. It's confidential. TomTec was a private company, so there's really, without being in the middle of the deal, you wouldn't know. There are other players that we have talked to over the years and continue to talk to, who are service providers. So the trend in analyzing images, MRI, PET scans, CAT scans, is to ship the images out and have them analyzed by an expert group, because it's getting more and more difficult to keep all that expertise going inside of a hospital. And again, the doctor, in our case, the cardiologist, can make a lot more money for the hospital by seeing another patient rather than sitting in a dark room drawing circles, which is the way they describe they currently analyze ultrasound images. So ours is a much faster way to do it, but still they will probably, there are some hospitals will be definitely sending out at least the more difficult cases, the ones that have the blurriest image, for outside analysis, if that were possible. So I think we can bring a service function to cardiac ultrasound. Well, so we have growing sales, we have recurring revenues, we have 80% margins, so we're a very attractive takeout opportunity. This is my 7th time around. I've done this 6 times. I've sold my companies to Pfizer, DuPont, Boston Scientific, and affiliates, and the products that I've created in all those different companies over the last 40 years have been used 300 million times to extend people's lives. So I worked for Pfizer for 2 years in their acquisitions group and acquired companies after they acquired mine. So I've been on both sides of tables. I know what it's going to take to get somebody interested in this table, in this company, and I know where we have to position the company and how much strength we have to have the company to do a decent deal with a multinational. Desmond Herzon comes to us from Fuji, which was formerly from Sonosite. Sonosite was bought by Fuji. Desmond was the person who created all that products, and Fuji paid $1 billion for Sonosite, and Desmond was the guy, the magic guy who made all those products work and clinically. And he's the person who's taken us from version 2 to version 3, invented the new tracking system. So I can't say enough good things about Desmond. Alvira is our head of everything regulatory. She's the one who keeps us all our ISO and all the various things up to scruff, as well as runs a manufacturing operation. And again, absolutely stellar person. Dave McFerden comes to us from the head of sales for Siemens. He's been 30 years selling capital medical imaging equipment to hospitals, so he clearly knows how to get this job done as well. Good, so that's the opportunity. Substantially de-risked because we have regulatory approval, very under cap, the current valuation is very low. If I was a pharmaceutical company that had been through the FDA 3 times with an orphan indication, I would have a market cap of 200 million, not 30 million. We're at that tipping point where people are beginning to see the value that we're bringing. And now that COVID all the heart problems go along with COVID, people are really sensitized to that. And so part of that is why our share price has gone uphill in the last 5 weeks. The other thing is that, we are now debt free and we have 2 years of cash in the bank. So we are in very good shape to capitalize on the opportunity. There we go. That's it, Anthony. Happy to answer questions.
Thank you, George. Great presentation as usual. And it's obviously really excited what the company has going on. And as I mentioned earlier in the presentation, the slight little pullback in the stock, I think, creates a very attractive entry point for those who aren't in the stock yet. So I just want to open it up for questions now. If you have any questions, just click on the raise your hand icon and I'll enable your mic, or simply type your question into the Q&A box. I know we already have a few already, but let's see here. I'm just going to read these right down the list. I think who buys your machines, individual doctors or hospitals, or both? I'm assuming it's most likely hospitals.
We currently market them directly to hospitals mostly. But roughly every 3 cardiologists in the world share echocardiography machine and ultrasound machine. Most of those people have them actually in small offices right beside them. But so we will get, and in the United States, of course, there's a lot of strip mall kind of imaging centers, which interestingly, they were being bought up by the hospitals because they saw them as competition. And now, of course, people don't want to go to the hospital to have their echocardiogram done because they're afraid they'll get COVID. So the strip mall centers are now coming back. So it's an interesting marketplace. But yes, we would sell. Anybody who's got a cardiac ultrasound machine would want to have one of these to be able to do a better job characterizing the heart that they're trying to treat.
Yes. And can a patient be taken from diagnosis directly to an operation, e.g. for example, for a potential heart attack? I mean, is the turnaround that quick?
Yeah, I mean, you wouldn't stop to do volumetric analysis on a left ventricle or right ventricle if the person had severe chest pains and it's clear they had a heart attack. You'd do a very quick ultrasound, see that you've got bad wall motion, some part of the heart isn't moving, which means it's dead, which or at least ischemic, in which case you would immediately go to the cardiology suite, cath them, and put in and do a angiography, verify the vessel, and put in a stent or do an angioplasty. So that's not something we would get in the middle of. We're dealing more with where you have a known heart problem, or you have suspected valve problem, or especially if you have a right heart problem, and you're now going down, where you have to be seen every 3 months, and your drugs have to be modified, and you're at risk for having to have your valve is leaking or something. And so now they're monitoring your heart every 3 months to decide when it's the right time to go in and do the surgery and replace the valve or fix the valve. Those are the kind of situations that we would be suited for.
Yep, exactly. And can you talk a little bit? One of our attendees is asking if you have to insert wires into the patient's chest, or are they like leads attached to the chest, similar to an EKG? Can you talk a little bit about, how the actual, I know you have a picture on the slide, but can you talk about how?
It's just standard 2D echocardiogram. We're not doing anything different than you would do. All we do is have a sensor on it, which tells you where you're aiming the probe when you take the slice to the heart. There's nothing you do. It's just a little goop on your chest, and away you go. There's no needles, pins, or anything. It's totally non-invasive. And one things we have. Another one of the improvements that we made from version 2 to version 3 with the new tracking system is that we got rid of any magnets anywhere in the system. Our old system had a magnetic tracking system. If you have any magnets anywhere, you can't do patients who have pacemakers or defibrillators or any kind of ICD, which is about 20% of people who actually have heart problems also have pacemakers or defibrillators. So, we've now eliminated that. So we actually increased our number of people you can use our device on to everybody now. There's really no patient, no matter what. The stents are not going to be a problem. So Yeah. So again, if you have a pacemaker or, or a defibrillator, you can't go near an MRI. So we can now do people who can't even if they're willing to lie there for 2 hours motionless, they can't because they have metal in them. Yeah.
That's a excellent feature. Um, is the reimbursement code the same for Medicare?
It's a Medicare, Medicaid, third party, Aetna, it's all the same. Everybody uses the same codes. It's just a different, you get a different fee from a different third party payer. And actually, even if it's Medicare, a different state, you get a
Yeah.
different number for every state. That's just the way the US works. But it doesn't vary that much. And the code's not overused. So there's no pressure on that code. What I should have said, and I usually say as I go through there, but I'm trying to make this a little faster than usual. It was that, we are eligible to go and get our own CPC code, okay? Reimbursement code. And we just need 3 hospitals to endorse the product. We generate exactly the same information you get from MRI. You get paid $1,200 to $3,000 for doing an MRI. You actually lose money on doing the MRI because 2 hours in the MRI costs more than $1,200.
Yeah.
Just in maintenance and capital cost and operators and everything. We would be able to get the reimbursement experts I've talked to said that we're about $500 to $600 reimbursement code. Which case, when that happens, we would increase the price of buying the machine to $300,000 and increase the per use fee to $250. And they would still be, the insurance companies love it because, and the hospitals love it because they actually make $250 to $350 profit instead of breaking even by doing an MRI. So everybody wins. So that's the plan.
Absolutely. How much has been invested in R&D already?
$30 million.
That's from the start from inception.
Yes. Well, that's our carry forward loss or whatever you want to call it.
Yeah.
I mean, some of that's obviously G&A and marketing and stuff. And so probably the R&D portion of it was most of that, probably 20 million would be R&D, and the last 10 would have been running a public company for 12 years. Yeah.
Have any sales been made to university/professional sports teams to monitor their athletes? Is there a possible market in this area?
I mean, there is, especially now that athletes have been shown to have heart defects. And actually cardiac ultrasound is used in a number of athletic programs to, as part of the training program to make sure that, the athlete is pushing themselves as hard as they can, but they're not pushing it so far that they're doing heart damage. So actually there are a number of centers who use cardiac ultrasound as a way to make sure the athlete's not being damaged by the training program they're on. So yes, there is an opportunity there. The opportunity for us is really to get it into the key centers and then see where that spins out. I mean, once MD Anderson starts using it and buying machines, that there are thousands of cancer hospitals in the United States. So there's a huge opportunity to exploit that vertical. So we are working on an alliance with a major cardiovascular company for their salespeople to represent us in the United States and elsewhere. We hope that will come to fruition, in which case we'll have a number of seasoned salespeople who are already calling on cardiology units and would be then introducing all those people to our technology and our way to use our system to characterize hearts. That's really how, once we do that, then we'll have all the horsepower we need to go after the athletes, the strip mall guys, the individual doctors, as well as the major hospitals.
Great. And would you be open to getting sales leads? One of our attendees may have connections. Is that something that you'd be interested in?
Yeah. No, it's all about getting it out and getting sales. I mean, we have over 200 scientific publications in top medical journals like JACC and JCI and Circulation showing that it works. It's equivalent to MRI. There's no doubt about all that. The issue is just being usability for the last 3 or 4 years, and we fixed that. Desmond has fixed that with a new tracking system. So we're ready to go. We're absolutely ready to go. It takes, one person 5 hours to make one of these machines. I can train someone to make one in half a day. So in the same 5 hours. So, I mean, we can make we now have totally remote installation, calibration, and training. It takes, the last one we installed, which is in King's College in the UK, took us 10 minutes to install it and 10 minutes to calibrate it. So
Wow.
it's over the internet. So it's, we can put these things in, build them and put them in extremely quickly. So yes, any sales leads be fun. I love talking to cardiologists who get the idea of exactly, for so many years, they haven't been able to even begin to look at the right heart and get any kind of useful numbers. So for them to, be able to get really MRI grade information in 5 or 10 minutes is almost unbelievable to them. So yes, I love, and yeah, send them on.
Yeah, I will definitely connect you both. Um, so can you speak a little bit about competition and your competitive advantages? I mean, we know your competitive advantages compared to your typical MRI scans, but you guys are pretty much, in this space. Um, I, are you ever without competition? But I mean, I feel like you.
Well, I mean, there's 3D, there's such thing as 3D echocardiography. So that's, you take a holographic picture. So, I mean, the holy grail in this business is to try and get it, take one picture, a holographic picture, a 3D, and then have it analyzed automatically, actually, without an operator involved. But that requires you have a very clever operator who knows how to run a 3D probe, which takes about 6 months to get really good at doing that. And then you also have to have, a good image. And unfortunately, and even though 2D's been around for about 15 years and every year it gets a little better, it's still not good enough to be a clinical tool. So you only get useful images on normal people about 65% of the time. On patients, it's less than half of that. So nobody wants to use a tool that only gives you an answer 1 out of 3 times on a
Right.
patient. And that's for the left side of the heart.
Mhm.
On the right side of the heart, forget it. You're never going to get, you will get good images eventually, but right now it's very, very poor quality images. So nobody uses 3D clinically. It will get there. I think we can help that because part of the way we use sparse data and our AI, we don't need really good images. In fact, we've already done the study on 2D ultrasound images, which were unreadable. About 10% of people give you poor images. And that's just the anatomy of the body and the physics of sound. There's just not much you can do about that. If you're not echogenic, you give poor images. But we've already shown that we can analyze 100% of the unreadable studies in a study at Masankowski Heart Institute in Edmonton, and that's been published. So we believe we can do even better in 3D. So I think we can bring 3D from a research tool to a clinical tool. And we're in the process of doing that research right now. So our competition historically has been people waiting for 3D to get good enough to use. And the 15 years of waiting, people are beginning to think maybe I should get something for now.
Yeah.
And COVID is also driving that discussion about, we can't wait any longer to get something where you can actually get useful information about the right side of the heart and also the left side. We do all 4 chambers. In fact, we're about to do a study of all 4 chambers in certain patient populations where that information has been lacking, but has been sorely needed and where. And the other thing is, I'm being told by cardiologists all over the world now that their radiology group, their MRI group is saying, don't even think of sending us a patient for 2 or 3 years. We are so backlogged. And they also, I mean, there's a publication put out, a global publication put out about 3 months ago saying that worldwide, the echocardiography suites worldwide are only running at 20% capacity. And they've been doing that for over a year. So the backlog in just routine patients for echocardiography is enormous. And you add on to that COVID, there's just no way that the existing base of ultrasound centers are going to be able to cope with all of those patients without rapidly, greatly accelerating the speed at which they do exams and the accuracy at which they do exams. And you're not going to get in, MRI can be so much more usefully used for other kinds of patients, cancer patients, liver, kidney, brain, all that stuff, where you get the scan done in 10 minutes, 15 minutes, not 2 hours. And again, you know, hospitals are motivated by profit. You don't actually make any money doing a cardiac MR. So they're the first ones to say no more of those. So I think echocardiography is the future, and the patient. I mean, an enormous number of patients coming out of COVID, apart from the aging population, which almost every country in the world is showing that we're going to have twice as many people with heart disease 20 years from now as we do now, just because of aging. So it's all indicators point towards a need to do things better, faster, and that's what we represent.
Yeah, and in terms of just efficiency, when you compare how many patients, you know, a cardiologist could see with, you know, Ventripoint's product versus a traditional MRI, it's got to be 5-10 times as many.
No, traditional MRI, you book 3 patients for a whole afternoon.
Right.
You know, if you told a cardiologist they're going to see three patients in the afternoon, they would throw you out of their office. I mean, come on. No. Cardiologist, a typical echocardiographer would read 30 studies a day.
Wow.
30. Okay. And of those, 3 or 4 would be unreadable. Just, you know, they would try for half an hour, 3/4 an hour to try and make head nor hair out of that study, and then finally throw up their hands and write unreadable on the chart, and that's it. So, you know, 10% of the time, you know, the healthcare system spends a lot of money doing an echocardiogram and then throws it away. Whereas we can salvage that. There's more than enough information in there to get an accurate and reliable measurement of the function of all 4 chambers of that heart.
Yeah. I mean, the point is the turnover, and could turn over so many more patients. It's just such a much more effective system. So,
Well, and the other thing is, I mean, in the United States, again, you know, hospitals are penalized for readmission. So if you have a cardiac patient comes in, usually takes you 6 or 7 days to, you know, dry that person out. They're usually got volume overload. You got to reduce their overall blood volume and stabilize their heart and do an echo and figure out what's wrong with them, and then put them on drugs. And it takes about 6 or 7 days. It's about $25,000 worth of health care. And then you send them home. And unfortunately, 25% of the time, that patient comes back within 4 weeks, within 30 days. And the way the healthcare, the U.S. decided to deal with this is to penalize hospitals whose patients come back too often, too soon and too often. So, you know, most hospitals in the United States run at, you know, 1 or 2% profit margins. They actually can be penalized 3% of their total billings to Medicare and Medicaid for too high a readmission rate. And, you know, you can go on, there's a public domain, you can go look up every hospital in the United States who pays the penalty and how much the penalty is. And so doing a better job on characterizing what's wrong with this person's heart and doing a better job treating them means they don't come back within 30 days. And if they don't come back in 30 days, then you're way ahead as a hospital. So I once did an analysis to show that, you know, our machine would pay for itself in something like less than a month, just based on getting out of the penalty box.
Yeah, no, which is incredible. And one last question, then I think we can wrap it up. Can you talk about the announcement that you just made concerning distribution in China? I think that was an important one.
Sure. So we've had a Chinese partner for the last 5 years. So they've been working through the Chinese system and gotten the product approved in China. They've set up a pan-China distribution network. They built a factory in Nanshan. It's a city sort of halfway between Beijing and Shanghai. I've been there. Beautiful, beautiful facility. And they're all ready to go. They put 8 machines in top 8 hospitals in 3 different provinces, which represent about 170 million people. And so they're ready to start rolling that out. They just got it listed as a reimbursable procedure in one of the provinces, Anhui province, on that. Because so, you know, China works. You got to get the procedure approved as a reimbursable procedure, then you can do it and get paid for it. So, and they're going to work their way through the other provinces and get that all done. So They're expecting significant sales this year, and we own. And so we help them with engineering, we help them with the regulatory, we help them wherever way we can, and it's a huge market. 34,000 hospitals in China. They build 1,000 new hospitals every year. Unfortunately, they have the top 5 risk factors for heart disease. They have all 5: obesity, diabetes, smoking, alcohol consumption, and bad cholesterol. So they have them all. And attempts by the Chinese government in the last decade to reduce risk factors has been unsuccessful. So they have a huge acute care problem with hearts. The average admission rate in Canada, United States, Europe, for a hospital is about 13% of people come in and are admitted because they have a heart problem. In China, it's 23%. So every 4th person in China is admitted to hospital because of a heart problem.
Wow.
So they just keep building more and more hospitals to deal with more and more of these patients. And a recent study I quoted in the press release was that recent study said that due to aging and also due to an inability to change the risk factors, means that China is going to have to spend an extra $7.8 trillion in the next 15 years dealing with cardiac disease, heart disease, over and above the trillions of dollars they already spend on the current problems. The problem will double itself in the next 15 years.
That's going to be a tremendous market for you.
So, I talk about billion-dollar markets. They talk about trillion-dollar markets.
Exactly.
Yeah.
But I think we're going to leave it there. Great presentation as usual, George. It's really exciting what is going on and different markets you're expanding into, and the tremendous market that I think COVID's going to present when the dust settles. So but we really appreciate you coming on today and getting us up to speed on Ventripoint, and we look forward to having you on again in the future.
Okay, well, happy to be here. If anybody has any questions, send them through to Anthony, and he'll forward them on. I'm always happy to answer questions. I've been at this for 10 years, and there's no question. I'll be amazed if you could send me a new question.
Yeah, I know. Well, and I am definitely going to connect you with the person who may have some leads for you. But in the meantime, if you need any additional information, you can reach out to myself, Anthony Alaka at Torrey Hills Capital, or George, or you can visit the company's website at ventripoint.com, including details on the VMS 3.0 system, as well as additional information and press releases. I know they just upgraded their investor relations page. There's a lot of great information on it. But I want to thank everyone again for joining us and taking the time to learn more about Ventripoint Diagnostics. And we look forward to having your attendance at a future podcast produced by Torrey Hills Capital. Until everyone, be safe, be well. Thanks again, George. And we'll do it again soon. Take care.